Okay, good evening everybody, and you're very, very welcome to Engineers Ireland and Clyde Road this evening. And for those then that are watching online, I also want to welcome them to tonight's proceedings. So I'm delighted, John O'Sullivan is my name, and I'm delighted on behalf of the Civil Division in Engineers Ireland to be introducing this talk, which promises to be very interesting and very, very topical. And it's a co-hosted event with the Civil Division in Engineers Ireland and the Institution of Civil Engineers Republic of Ireland branch. So the talk itself is going to be very, very topical because Dublin Airport for infrastructural development is in the news currently. And the background to the talk is that given the ever-increasing air traffic volumes being experienced by Dublin Airport, together with the expected introduction of long-haul flights, together with the booming economy that we're experiencing at the moment, that this has necessitated an upgrade to the fuel storage infrastructure at Dublin Airport. So tonight's talk is going to detail that infrastructural upgrade works from initiation to tender all the way to the construction and design phase. The presentation is a multi-speaker event, so we have 4 speakers that will present in 5 pieces. The first speaker is going to be Colman Horgan. Colman is an engineering graduate from UCD. He has 30 years experience in civil, structural and bridge engineering. Colman joined the Dublin Airport Authority in 2012 and is the current airfield delivery manager for infrastructure projects at Dublin Airport. Colman will be followed by John Pitts. John Pitts is founder of eJet, and he's an acknowledged expert in open access fuel supply operations, having 30 years of national and international experience that incorporates work in Hong Kong, Dublin, Delhi, and Bangalore, to name but a few places. The third speaker will be Cormac Bradley. Cormac is a construction manager for RPS. Cormac is a current member of the Civil Division in Engineers Ireland and is the current chair of the Institution of Civil Engineers Republic of Ireland Division. Cormac is an engineering graduate from Queen's University, Belfast. He has 30 years of national and international experience in the delivery of civil and structural engineering projects. And the final speaker this evening then will be Ibon Ibarrola Armendariz, and I hope that I pronounced that correctly. In 2016, Ibon started CLH Aviation Ireland, a fuel specialist company. He originates from Bilbao in Spain, and he has 17 years in the delivery of national infrastructure associated with aviation fuel farm, the management and operation of same. So before I begin, one of the things I meant to mention was that we have 2 exits, emergency exits, if they're needed this evening. One of them is on the left corner of the room, and the other then is the door through which most of you came or entered this evening. So without further ado, I'm going to hand over to Colman Horgan to get the presentation underway.
Thanks very much, Sean. I'll be brief. 6 years ago, I was working in Dublin Airport as a project manager. And it was about this time of year, and it was about this time of the evening, I was sitting at my desk when a friend, and I'm using the term very loosely given what he's done to me, dropped down to my desk and said, "Would you have 10 minutes to look at something with me?" And he handed me a document known as the IATA Fuel Storage Guidelines. And it's a very slim document, and it's supposed to be kind of all you need to know about fueling operations, and it tells you very little. And our problem at Dublin Airport was that our fuel storage facility, which had been built 40 years earlier, was no longer fit for purpose and was barely able to manage the storage demand that we had at that time. So we'd gone to the regulator looking for money during the SIP process. It was a 2009 till 14 one, I think. And we sought monies, and we were granted a certain amount of monies, but like all a common problem in our industry, the monies we were given weren't sufficient to match the estimates that we'd put together for developing the full facility. So in the guideline document, it mentioned the branch of mathematics known as optimization. And it set out a series of guidelines whereby you were to study your supply chain, you were to estimate the risks involved, calculate your demand profiles, and then it would spit out a desired storage. And we started off down that route because for my sins, I'd studied this branch of mathematics a year earlier. And two things jumped out. The first was we knew nothing in Dublin Airport about our supply chain. We'd no idea of where the fuel effectively came from, how it got delivered, who brought it, who were the parties involved, and what were the risk profiles of all these parties. And we set out on a long profile of learning our industry and the risks to it. Because, as we discovered, like there's a phrase that simply, if there's no fuel, there's no flights, nothing takes off, nothing moves. And the second thing jumped out was that this was going to be a very long, a very complicated calculation. And the result it would spit out wasn't necessarily something that you could place huge reliance, because it was based on a lot of assumptions on the inputs. So, around the middle of 2013, a business decision was made to directly consult with the airlines and say, what do you think? And we went to the airlines with a series of questions. One was, should we go down the DFBOT route and procure a specialist company to design, finance, build, operate and transfer the facility? Two is, should we build 3 tanks? 3 was, should we activate a hydrant that had been constructed as part of the Terminal 2 Pier 4 development? And a number of other questions. And resoundingly the airlines, because the airlines were much more tuned into the fuel issue than we were, because it was the core part of their business. And they resoundingly came back and said, yes, you should, and you should have been doing it years ago. So like all good project managers, which I was at the time, I sat down and wrote something called an RFT, a request for tender. And I procured the services of the 2 companies represented by John and Cormac here. With their help, and I have to say I'm very good, and I say this rarely in life, an excellent solicitor from Arthur Cox is named Aaron Boyle. We sat down and wrote a series of documents, of which there were many, and we procured the services of a company represented by Ibon tonight. To say that this project is challenging doesn't even begin to describe it. It was challenging, and it still is, and we've a good bit to go yet with it. And all I could say is, if I knew then what I know now, I would have looked at my friend and I would have ran. So without further ado, I'll pass you on to the excellent hands of John, and we'll take you through the project.
Thank you, Colman. Good evening. Before we get into the project itself here in Dublin, we thought it was worthwhile talking about the industry and placing this project in the context with which, as an international airport, Dublin sits. So I'm going to talk about the industry in the first part of my talk, and then going to hand on to Cormac, and then I'm going to come back and talk about the remaining bullet points below the line, which are of a more commercial nature. A little bit about eJet. We are aviation fuel specialists. We provide services to the aviation fuel infrastructure industry, commercial, technical and operational services. I started my career with Shell back in the mid-80s. Almost all of my career has been in the aviation fuel part of the business. I was general manager of the fuel consortium in Hong Kong that delivered the largest piece of fuel infrastructure at an airport in a single phase, $250 million US. That was 20 years ago. Since then, eJet has been based in the Far East and now back in the UK. We're based in the southwest of England, and we cover the world from that base. The international aviation industry is global by its very definition, so we tend to work wherever airport developments are taking place. And in truth, airports are developing universally. All airports are by some measure growing as air transport and the demand of the flying public shows no tendency to abate. Aviation fuel, if you think about it, is pretty well the only component of flight which doesn't have any redundancy, which is not duplicated. Aircraft have multiple engines. They have redundancy in control surfaces, several hydraulic systems, several electrical systems. There are 2 people in the cockpit and they each eat different meals. The fuel comes from one place, and it has to therefore meet and adhere to extremely stringent quality control requirements and must not be corrupted at any point through its journey through the supply chain. In terms of the industry itself, IATA, the International Air Transport Association, recognises about 4,000 airports which offer some form of commercial service around the world. And that can be from the major international hubs like Dubai, Singapore, Heathrow, Dublin, down to upcountry airports where there may be 2 or 3 flights a week. Beyond that, ICAO, the International Civil Aviation Organization, the UN body, counts about 40,000 airfields where some form of flight is taking place, and some of those are on a commercial basis. So in total, there are around about 100,000 flights a day taking place. I put there are about 100,000 fuelings, because generally commercial aircraft will be fueled before it flies, before each flight. There's no point flying fuel around the sky because it weighs a lot, so the aircraft will fuel its requirement for the next sector at the departure airport. It's not always the case. If an airline has any concern about security of supply or fuel quality at a particular airport, it may not uplift fuel at that airport, or if there's a concern about price being uncompetitive, it may bring some of the fuel it requires for its next sector with it from the previous airport. So airlines have some form of choice, but in general, each flight is fueled with a quantity of fuel before it departs. And at every second, about 8,000 to 9,000 litres of jet fuel is consumed by the industry. So in the course of about 2 or 3 minutes, this room, if it was full of fuel, would be emptied. It just gives some food for thought. Dublin is growing strongly. When we started on this project, the daily fuel uplift was something around about 2 million litres a day. It's now at least 3 million, and in the peak periods of the summer, it's up to about 4 million litres a day. So considerable growth. The industry itself, aviation is growing at about 5% a year, civil aviation, and because the airline fleet is getting more fuel efficient every year in general, because more fuel efficient aircraft are entering airline use, aviation fuel demand is growing at around about 3% a year, and has shown that growth tendency to be very strong for many years to date, and is showing no sign of that plateauing off. It's an industry that is showing very strong growth. If an interesting figure here on the screen in the context of Dublin is that the fuel uplift from Dublin Airport on a daily basis, or even an annual basis, is approximately the same as Ireland's gasoline or petrol demand as a country. So aviation fuel out of Dublin Airport is a large quantity of fuel. In context, Heathrow, Hong Kong, Dubai, those mega airport hubs are probably in the region of about 20 million litres a day, or 16,000 metric tons. In terms of where Europe sits globally, about 20% of international jet fuel is delivered and used in Europe. North America is representing about a third of jet fuel volumes. 20 years ago, about half of jet fuel volumes were consumed above continental United States. With the burgeoning growth in Asia, particularly China and India, the centre of gravity is moving towards the east, and Asia Pacific is now well above a third of international fuel demand, and that's where considerable growth will be seen in the next few years. A little bit about fuels themselves. What we're talking about tonight is jet fuel, which is a kerosene type material. It's almost exactly the same as heating oil you might have at home. barring a few differences, and those differences are specifically the quality control requirements placed upon that fuel. Jet fuel doesn't move without being accompanied by a certificate attesting to the quality of the fuel in question. There are several types of jet fuel. It's an international industry and different regions have different specifications, but they're all generally the same, and the industry is trying to harmonise jet fuel standards with degrees of success. In this part of the world, in Australia, in most of Asia, most of South America, it's Jet A1. In the USA and soon to be Mexico, which is undergoing a shift, it's Jet A, which is a very, very similar type of product. It differs in two particular characteristics, one of which is its freezing point, and the other is to do with its static electrical characteristics. As a world volume, Jet A1 is the most important type of jet fuel. The GOST and the other types are Chinese and Russian types of jet fuel. As it is a kerosene product, it's relatively non-flammable. There is an old adage that you could throw a lighted match into a bucket of jet fuel and the match will go out. I've not seen anybody try that, but I have always been led to believe it's a truism. I'm not recommending anybody goes home and tries it either. What jet fuel is susceptible to contamination. It's relatively easily contaminated by dirt and water that it might pick up in the rather complex supply chains that I'm going to talk about in a moment. So a major exercise in managing supply chains, in delivering reliable large quantities of jet fuel to airports, is keeping it clean and keeping water out of it. Fuel naturally has a water content, whether it absorbs it from atmospheric humidity, whether it is water that is chemically bound into fuel molecules as a result of water absorption into solution. It is also susceptible to microbiological growth. Clagosporium resinae is the best known contaminant in that regard. And if you get this sort of contamination in the supply chain, say in the airport tanks, it's a major problem because it's very difficult to get rid of. So housekeeping in fuel farms, in pipelines, is extremely important in the industry. If water is present in jet fuel in an undissolved form, whether it's suspended or free water, at high altitude where aircraft, particularly on long haul flights, have a cold soak at about minus 56 degrees centigrade, that water can come out and crystallize and risk blocking fuel filters on aircraft. Most large aircraft have heaters on the fuel filters, but there has been one particular incident that was traced back to a particularly long cold soak of an aircraft and ice forming on the fuel filters that couldn't be eradicated. I mentioned static electricity a moment ago, and that is something that has to be monitored and watched throughout the supply chain, because jet fuel, particularly when it is passed through filters and fuel is filtered whenever it is moved from point A to point B, has a propensity to pick up or accumulate a static charge. And if not dissipated, there is a risk that there can be an explosion. And this has happened on one or two occasions. So fuel contains a static dissipator additive to help relax any static charge that it may accumulate. The aircraft in the bottom left-hand corner is a Boeing 777, and as an indicator, that aircraft can depart with maximum fuel load of about 170,000 litres or 135 tonnes of fuel, and at a modern airport that fuel has to be delivered into the aircraft in less than an hour because of turnaround times. Aircraft don't make any money when they're sitting on the ground, they have to be kept flying. The other broad family of aviation fuels are gasolines. Similar to petrol, in an automotive sense, used in spark ignition engines. And these tend to cause more of a headache than perhaps the small volumes that they represent justify. But because they're used in small aircraft, general aviation, generally aircraft with a single engine, they need to be monitored very, very carefully. If the wrong fuel gets into one of these small aircraft with a single engine, it's going to be a big problem, and there have been a number of accidents as a result of misfueling. So the industry is very, very vigilant to ensure that the wrong grade of fuel does not get onto the wrong type of aircraft. With large commercial aircraft at a major airport like Dublin, it's relatively straightforward because only Jet A1 is handled on the major parts of the airport. There are selective couplings that mean that the wrong hose cannot be connected to a particular aircraft type. But with small aircraft like this, which are fueled over the top of the wing through an orifice, it is possible, and it has happened, that jet fuel has been mistakenly fueled into an avgas requiring aircraft, and there's been an ensuing incident or accident. There are several types of avgas around the world, and the 80, the 100, the 100 LL designations principally refer to the octane rating. It's similar to the octane rating of petrol. It's not exactly the same because an aircraft engine has to perform under different conditions from a car. They spend much more of their time at maximum power, and the operating conditions are very different because at altitude temperature is lower than on the ground. They have to be able to fly through clouds without failing, etc., etc. So it's very different from the performance requirements of road vehicles. How much fuel does an aircraft take? Well, an aircraft takes almost exactly as much fuel as it needs for the next flight. This Boeing 747 has a total capacity of about 216,000 litres spread around the aircraft, mostly in the wings. There's a tank in the tail that is filled for ultra-long haul flights and is also used for trimming purposes. The largest tank is in the belly, the centre wing tank, and that is the tank that is not always or even often filled unless it's an extremely long-range flight, because bending relief from the weight of the fuel in the wings helps offset the weight of the fuselage, and therefore the further outboard the weight of the fuel is, the better the cantilevering effect, and the lighter the wing structure has to be. As I mentioned, in order to achieve the turnaround times that modern airlines require, large quantities of fuel have to be put onto aircraft in a relatively short turnaround time. I'm going to go on to explain how that is done in a moment. Firstly, looking at supply chains, they are quite complicated. Fuel always starts at a refinery. And when I say always, that's probably a guarded statement, because now we're looking at fuel components from other sources, and the starting point might be a forest or a cornfield, because renewable fuels, sustainable fuels, biofuels are becoming a reality and can enter the supply chain on a drop-in basis. In other words, the fuel that is manufactured in a sustainable way has to look and smell exactly the same as jet fuel from a traditional source and be dropped into the supply chain. So it may enter the supply chain at another location as opposed to a refinery. I said that supply chains are complicated. They're getting more complicated. It used to be the case that oil companies refined crude oil into products. Those products were distributed through pipelines in ships, by train and by road, to intermediate storage terminals, or perhaps directly to an airport. And once the fuel reaches the airport, it's then delivered to aircraft in one of two main means that I'm going to describe. Supply chains are now much more fragmented, and there are other parties involved in those supply chains. parties that take a position maybe for commercial reasons, commercial gain, short-term, long-term, traders, banks, other forms of financial institution, they're all active in supply chains, and the major oil companies, while still very active in marketing fuel to their own airline end customers, may not be represented throughout a complete supply chain as perhaps they used to be at one time. What you may notice on this picture is that there are several occurrences of what is called a filter. Every time jet fuel is moved, it is filtered. The filter is used more or less as an insurance policy to make sure that fuel is ultra clean. Housekeeping procedures should mean that the filters don't actually have to do very much work. But there's some very sophisticated filtration used in the industry, and I would say that the largest R&D spend in the industry is in filtration, whether it's micronic filtration down to half a micron, 1 micron of cleanliness, or whether it's another type of filtration which actually strips water out of fuel from it being in finely suspended proportions. Filtration is key to handling of fuel. Looking at the airport, and this project at Dublin was concerning tankage and storage at the airport as much as anything else. Fuel tanks at airports can be very large indeed, and the ones in Dublin are right up there with class-leading airport sizes. Tanks can either be vertical or horizontal. At any major airport, the tanks are going to be vertical. Horizontal tanks, as in the bottom left-hand corner, are relatively small. These tanks, and they're photographs from Hong Kong, are 10 to 20 million litres each in size. There are various sizes there, and that can only be achieved by vertical tanks in the order of 25 to 40 metres in diameter and about 20 metres high. So the considerable structures, and Ibon's going to talk about the developments in Dublin in a minute. In order to satisfy the fuel quality requirements, tank design for aviation is quite specific. And what you can see on the sketches and what you can't see from the photographs, firstly, is that the tanks don't have a flat bottom. They have a cone down bottom. It's relatively gentle slope, 1 in 33, but that is intended to allow movement of any water and dirt that by gravity drops onto the tank bottom. Move it towards a centre sump, which you may just be able to see on one of the section drawings, in the middle of the tank, and standard operating procedures are to flush that centre sump out on a daily basis to check for any dirt and particularly for any water, and to purge it from the tanks. In order to facilitate this, the laying of the tank plates is such that water traps are avoided, and the tank plates are overlapped or underlapped to the centre, so that there is no positive barrier to water movement by gravity, but it's actually like descending a very shallow set of stairs. Ideally, jet fuel tanks should be freely vented so that any condensation due to or water vapour ingested into the tank as it breathes in can be expelled with the help of the heat of the sun as the tank fills and pushes water, air and vapour out of it. In some jurisdictions this is not possible, and tanks are fitted with pressure vacuum valves, and in desert conditions that's often advisable to avoid the tank breathing in airborne sand and dust. But ideally the tank should be freely venting so that it can assist itself to purge itself of water vapour. The last component I'm going to mention is a floating suction. That's the device in the left-hand sketch which is shown at the top level of the fuel, and is also shown in its descended position. This is intended to draw fuel for the pumps that deliver fuel to aircraft. It's intended that they draw from the cleanest point in the tank, which is the top level of fuel in the tank, on the assumption that the dirtiest or the least clean fuel will be at the bottom. So floating suctions are a key requirement of the industry. Some pictures of tank construction and the internals of tanks. Tank shell plates are butt welded together to form a concentric ring, and each strake of shell plates is butt welded to the one below and the one above it. In order to avoid water traps, to avoid or to prevent the free movement of water down the very shallow steps towards the centre sump of a cone down bottom tank, the roof of a tank should be self-supporting, and that presents sometimes some structural issues because it's much easier to put internal columns to support the roof. So a self-supporting structure over the size of some of the tanks that are required can present some challenges. Tanks are also internally coated with an epoxy material in order to keep the surface smooth, to show up dirt and to allow dirt to move and water by gravity towards the centre sump. And you can see some pictures here of the inside of some tanks. Of particular interest is the left-hand picture, because it shows a pipe support structure. If those channel sections were turned through 90 degrees, the inside of the channel could present a water trap, because water could accumulate in there and not be able to be moved towards the centre of the sump of the tank and be purged. And if that were to happen, it would be an ideal breeding ground for microbiological contamination, because the microbes require water to sustain life, and they feed on the fuel hydrocarbon molecules. So we want to avoid that at all costs, and hence design features like that, not having the channel section preventing or facing the potential flow, is one of the nuances used in design. How does fuel get from tanks to the aircraft in question? There are two main ways. One is a tank truck, which may be called variously a fueler or a bowser. These are pretty well always used at smaller airports, and to some degree at larger airports, where the other type of fueling, which is hydrogen fueling, may not be present in every case. They tend to be large vehicles, they tend to be cumbersome, they tend to have a high wear and tear component, because a fuel at an airport is considerably heavier, loaded to a heavier weight than the comparable vehicle would be allowed to be on the road. And turning radii on airport aprons are generally more severe than on the road. So wear and tear of driveline components and actually wear and tear of the driving surface is also greater for these vehicles. Most airports require at least one of these vehicles for what is called defueling, which is, as opposed to fueling an aircraft, putting fuel onto it, it is taking fuel off an aircraft if the aircraft were to go into the hangars for maintenance. At such times the aircraft would require the tanks to be empty from a safety point of view. So defueling of aircraft is, particularly at major maintenance bases, a required activity. The other form of fueling aircraft, and one that is the features at Dublin Airport, is hydrogen fueling. Rather like an urban water system and a firefighting hydrant system, a fuel hydrant is a network of piping underneath the airport apron. It runs underneath where the aircraft park, and it comes to the surface at off-take points on each aircraft stand. Aircraft park on designated stands, rather like cars park on a car park. They park, rather than between two white lines, they park along a centre line. And the off-take points, or the hydrant pits where the fuel comes to the surface, are spaced either side of that centre line, spaced and positioned appropriately for the type of aircraft that will be parked on that stand. And because airport authorities like to park as many different types of aircraft on a particular piece of apron as that they can, the arrangement of these hydrant pits can be quite complicated to ensure safe and efficient fueling. We have to try and avoid putting them close to the hot parts of aircraft, like the brakes or the rear of the aircraft engines, in case there were to be an accident or an incident and a spillage, because those hot components of an aircraft present a source of ignition. Hydrant systems are also particularly suited to high flow rate fuelings of large aircraft. That Bowser on the bottom left-hand picture would not be large enough to fuel the aircraft fully that it's parked under if that aircraft was taking maximum uplift. That aircraft might take 2 or 3 of those Bowsers in order to go on an extremely long haul flight. And the clustering or the congestion caused, the queuing issues, getting multiple vehicles of that type to that aircraft would mean that ground times of aircraft would be unacceptably long. The small vehicle on the right-hand picture would be capable of fueling that aircraft on the left-hand picture on its own in the required 3/4 of an hour period. Far less congestion on the apron, far less obstruction to other agencies who are trying also to service that same aircraft with catering, with baggage, with toilet facilities, etc. The smaller vehicle is much more efficient. A little bit of detail on the vehicles themselves and how fuel passes from them into the aircraft. The Bowser in the bottom left-hand picture is what's called a low-profile vehicle. It will fit under most aircraft wings, and that's a safety issue. Not all Bowsers can fit underneath all aircraft types. The vehicle has a filter. Yet again, the fuel is filtered as it passes through the supply chain. The bottom right-hand picture shows a hydrant dispenser, and it's connected to what we call a test rig, which is a device to simulate aircraft fueling so that the safety devices on the vehicle can be checked at regular intervals. The detail in the top right-hand picture shows 2.5 inch hoses connected underneath the wing of the aircraft. Large commercial aircraft are fueled under pressure by underwing fueling points, as opposed to the small monoplane single-engine aircraft we saw a few slides ago, which is fueled over the wing. Modern commercial aircraft, pretty well without exception, are fueled underwing by hoses, as shown in this picture. Finally, the hydrant system itself. It's a pressurized network of pipes that run underneath the airport. The lower picture shows the hydrant being constructed in a trench. That one is about 3 meters below grade level. Hydrant lines never run truly horizontally. They always run on some form of sawtooth profile, again in order to move any dirt and water to a point from which it can be purged, what we call a low point in the hydrant system. So hydrant systems longitudinally are always running on a upwards or a downwards profile. The drawing shows a riser coming off the main hydrant line, and that main line, depending on the flow rates that the airport has to support, maybe anything from 10 inches in diameter, 250 millimeters, up to 24 inch or 600 millimeters, or even larger. Some lines in Schiphol in Amsterdam which are 28 inch, and I believe in Abu Dhabi, the current terminal developments are even larger than that. Flow rates, total flow rates through these systems can be quite considerable. 50 to 60,000 litres a minute in the peak hour of fueling at an airport, at a major airport, are not uncommon these days. And airports generally show some peaking in fueling activity throughout the day, whether it's a nighttime set of departures from the Far East into Europe. The peak hour might be at 10 o'clock at night, or at an airport like Dublin there'll be a morning peak as business flights take off, and an afternoon peak when they're back again. But the risers come to the surface, and there's an off-take point. There's a valve known as a hydrant pit valve, which has several features that enable shut-off and control of flow, and that is connected to by an inlet coupler which mates to it, and which is part of the vehicle system at the end of what is normally a 4-inch inlet hose. And that small hydrant dispenser underneath the wing of that aircraft is capable of fueling a flow rate anything up to 4,500 litres a minute. So the flow rates that individual aircraft are experiencing at any time can be quite considerable, and the aggregate flow rate represented by several of those aircraft fueling simultaneously is considerably larger than that. What a hydrant system does do is that it connects the aircraft on the apron to an almost unlimited supply of fuel back at the fuel farm. And that is what a Bowser or fueler operation doesn't do. It's in discrete parcel sizes, whereas hydrant fueling, if the capital cost can be justified at an airport, is considerably more efficient in most cases. I'm now going to hand over to Cormac, who is now going to start talking about the project in case here in Dublin.
Thank you, John. So John has given us a very quick synopsis of what the aviation fuel sector is on a worldwide basis. So what are the issues specifically associated with with Dublin? Well, I'm sure most people in the audience are familiar with RPS, so I'm not going to dwell on that one for very long, but suffice to say that RPS consider themselves to be a multidisciplinary organisation, multidisciplinary consultancy. Even we go so far as saying we're a one-stop shop. Maybe not everybody shares that view, but that's certainly our estimation of what we do for our clients. We've made reference to the fuel capacity, the fuel storage capacity at Dublin Airport, and that is one element of the actual manifestation of the project. These are the 3 new 5,000 cubic metre capacity tanks, which effectively have increased the capacity of Dublin Airport by a factor of 6. And as you can see by the label, this photograph was taken in December 2017. What's of interest is if you look at the tank on the right hand side of the photograph, you can see the second concentric shell around it's a 2-shell structure, so to speak. The middle tank you can see is not quite so far up, and it doesn't have the outer shell, and the same with tank number 3, which is the one on the left hand side of the photograph. So these are at various stages of construction. So what's the specific background to Dublin Airport? Well, the first context is to look at passenger numbers. In 1950, 212,000 passengers passed through Dublin Airport. And when we were discussing this presentation today, the point was made that in 1950 you could probably drive your private vehicle out onto the airfield in order to get on board the plane. That's how simplistic air travel was in the 1950s. And when I say simplistic, of course, air travel itself was very sophisticated. Not everybody had access to it, but in terms of getting access to the plane, it was a very simple operation. By 2008, there had been a tenfold increase. Is that tenfold? Yes, tenfold increase in passenger numbers. So we got to 23.5 million with 210,000 transport movements, a considerable jump from the 1950s. However, from 2008 through to 2012, in parallel with the crash of our economy, passenger numbers dropped off significantly. But by early 2014, there had been 16 months of consecutive passenger growth, and that had manifested itself in 20.2 million passengers passing through the airport in 2013. So you can see that there's quite a bit of fluctuation, and that fluctuation in passenger numbers was mirrored by our economic circumstances here in Ireland. By 2014, when we were considering the tender process for the project, the projected growth for the Irish economy was of the order of 7%. Now that's a fairly sizable figure when you consider what had been going on for the previous 6 years. And our tender document, when we were drafting it, made reference to an immediate target of 25 million passengers per annum, or PPA. So you can see that the projection in 2014 was that that passenger numbers at Dublin Airport were growing, and the ambition was to get to 25 million. But ladies and gentlemen, by 2017, that figure had grown to 29.7 million. So that gives you an indication of the sort of growth that's going on at Dublin Airport. And while we couldn't have known back in 2014 that we would get to that number, it vindicates the decision to initiate the project by which we actually undertook the works that are being described here tonight. And the expectation is that that sustained rate of growth will continue through 2018 and beyond, to the extent that DAA have now modified their passenger number targets initially to 44 million and then onwards to 55 million. Now, when you consider that in the island of Ireland as a whole, there are probably only 6 million of us. So that's a fairly sizable number considering the size of the island. Okay, so passenger numbers was one element of it. Fuel capacity on site is another element of the decision to embark on this project, and those are the 3 existing tanks that have been serving Dublin Airport since 1972. They're each of them hold 800 cubic meters, and what we're finding is, what DA were finding is, in the period leading up to 2014, that 2,400 cubic meter capacity was effectively being consumed on the busiest day at the airport. And up until 2014, that was invariably one day in July in the busiest part of the airport's calendar. What we have found since then is in actual fact that there isn't a single day on which the 2,400 cubic meter capacity is exhausted. There are now multiple days. And in that context, that's why it was critical not only to build the 3 new tanks, but it was also critical to get one of them into operation as soon as was feasibly possible. And when I say that, that the supply, that the 2,400 cubic meters was exhausted, it's not that the tanks were left empty at the end of the day. What we're saying is that the throughput volume on a day's operation in July exhausted the total supply, because the fuel farm currently is being supplied on a 24/7 basis from Dublin Port with a fleet of barges that move from Dublin Port to airport to discharge their fuel and then go back to Dublin Port to be refueled again. One of the other consequences for Dublin is that the International Air Transport Association requirement is that an airport the size of Dublin should have on-site 3 days of operating volume. And what I've indicated from the previous bullet point, that in 2014 that wasn't the case. So while in essence Dublin was not operating in accordance with what IATA considered to be best operational practice. Another consideration was the age of the existing facilities. These tanks have been in operation since 1972. And as John has alluded to in his presentation, there has been a complete change in the mode of fuel supply to airports. So we don't have a situation where the big oil companies are managing these facilities. These facilities are now being managed by specialist companies such as Ibon CLH, and we'll hear more about that in his presentation. This isn't telling tales out of school. This graphic presentation of fuel demand up till 2014 was part of the RFI documentation by which we invited parties to express an interest in getting involved in this project. So as you can see, there's a progressive growth in fuel demand up until 2008, after which it falls, and the green column at the extreme right-hand side of the picture indicates what the projected volume in 2014 is. And what, if you look at it there, it's just short of 700,000 cubic meters. And yet we're talking now of the situation where we're getting into a very substantially bigger volume of fuel at present. So we've got a passenger issue, we've got a capacity issue, and let's look at some of the economic factors that influence the decision to embark on this project. Well, by 2014, almost miraculously, the projected GDP growth for Ireland was 4.7%. There was an expectation that that would increase over the following 3 years, which would leave us, and in 2014, we were effectively the third highest GDP per capita in the EU, which is quite an amazing statistic when you consider what was happening beforehand. At that stage, we were in the top 10 of Forbes' list of best countries for business. There was a projection that we would, within 5 years, have 10 million overseas tourists coming to Ireland. Aviation fuel tax had been removed, which meant that effectively the cost of the fueling operations was going to be significantly changed as a consequence of that removal. And most importantly, Dublin can boast that if you're going westwards to America, you can actually come into Dublin, you can actually pre-clear US Customs and Immigration before you actually leave Dublin. And if you read the newspapers and you follow what's going on in the aviation sector in this country, you can understand why Heathrow is very envious of that facility, and why the perception in the media is that there are machinations that London would like to be able to offer a similar service. So what we're saying is that in late 2013, as Colman has alluded to, and early 2014, there was a convergence of a number of different factors that effectively justified the embarking on this particular project. So it was passenger numbers, storage capacity at the site, which was influencing the operability of the facility, and in addition, the economic circumstances of the country as a whole. So, what did we undertake to do? Well, we undertook to build 3 5,000 cubic meter storage tanks. So you've seen the opening slide. There was an undertaking to build a pipeline to Pier 4, and Pier 4 is the pier that effectively services Terminal 2. That pipeline would be extended northwards in order to service Pier 1. As Colman has alluded to, at Pier 4 there was a hydrant constructed as part of the Terminal 2 works. It had been in the ground in dormant condition since the completion of Terminal 2, and one of the key objectives of this project was A, to feed it by pipeline from the fuel farm, and secondly to get it operational, and John has explained what the advantages of a hydrant-fed system are in the context of an airport the size of Dublin. Regrettably, and one of the challenges that again Colman has alluded to, is we're going to have to install a hydrant at Pier 1, and we're going to have to install that hydrant under operational conditions. So I'm expecting Mr. O'Leary to come out and supervise the works if I'm not available. Additionally, there is a requirement to provide a fuel pipeline spur to Pier 3 because of the particular requirement for certain larger aircraft to come into Pier 3. We've had to provide new operational buildings within the footprint of the fuel farm, and this came about as a consequence of a change in circumstance of the project. Originally, the intention was to build an airside hub which would accommodate the operational buildings of the team that manages the fuel farm itself, that housed the interplane agents who physically took fuel from the fuel farm to the aircraft and also service buildings and everything else. And it was originally intended that certain elements of that were going to be built airside, and then very late on in the day, a decision was made that in fact that amount of square meters couldn't be accommodated as a consequence of the airside operations. So in fact, those buildings all came back into the fuel farm. So we had a situation where we were trying to construct new storage tanks, we were trying to put in place new operational buildings within an operational fuel farm. And considering some of the risks that have been alluded to in the context of that, you can understand some of the challenges associated with QA in terms of making sure that the construction activities didn't interfere with the operation of the fuel farm. And not only did we have to build tanks and put in new buildings within the fuel farm, we also had to redevelop the fueling facilities itself. We've talked about the change of mode of loading vehicles, that we're actually trying to get away from loading Bowsers who then go out onto airside through security control, and instead putting in place a pipeline which is a more effective operation, which means that fuel Bowsers, for example, couldn't get stuck at the security gate in order to go airside, because there's a more discreet way of getting fuel to an aircraft faster, more effectively, and then more efficiently, without actually having to engage with any sort of ground interruptions or constrictions. Almost as soon as we started looking at drafting the tender documentation to acquire the services of a concessionaire to develop this particular project, the spectre, and I use the word very generously, of a port-to-airport pipeline from Dublin Port to the airport its profile rose again. Probably of the order of 10, maybe 12 years ago, there was some speculation that it was time to actually put in place a fuel pipeline from Dublin Port to the airport. Then we had the crash of the economy, it went into mothballs, and literally months into the consideration of a tender process for the works that we're describing here tonight, the port-to-airport pipeline came back. However, it's very important to point out that it's a private enterprise. DAA don't have any involvement in it. They're obvious beneficiaries as a consequence, but they are not one of the investment partners in the port-to-airport pipeline. And of course, with everything else, it's a very strenuously regulated sector. There are large statutory obligations as well. We've talked about IATA. We've talked about, for example, you will find later on there are other parties who have a statutory oversight of the project. And of course, given that we're putting in place pipelines, we're putting in place buildings, we're putting in place tanks, there are a whole suite of contract specifications. So, time for a picture. This is the foundation for one of the first tank, which was tank number 3. The foundation was a very simple U-shaped cross section of reinforced concrete. As you say, it's a fairly dense reinforced section, but it's not particularly complicated. The channel between the two concrete sections is effectively a drainage channel, and then to the left of the reinforcing where the ladder's sitting, it's effectively a donut. So what happens is inside the core of the donut, so to speak, is backfilled with gravel and stone and everything else in order to provide a sort of flexible bottom to the tank in accordance with the cone characteristics that John alluded to in his presentation. So this tank was put together this would have been the summer of 2016. Yeah, summer 2016. The first tank number 3, the foundation was poured in 3 different sections, and then we subsequently poured it in 2 sections in order to not accelerate. You don't use accelerate in a construction environment, but to reduce the window of construction for the foundations. Dublin Airport Authority is a multifaceted organisation. We have a situation where there are airport operations, we've got landside operations, we've got the fire brigade, we've got police, we've got planning, we've got finance, we've got strategy. And all those entities within DAA had to be consulted about the project, what the implications were for them. And that led to some of the changes in what we were proposing to do from a works perspective. We also, as Colman has alluded to, there was engagement with the airlines because the airlines had a significant influence in how we were going to configure the works. For example, the decision to go with 3 tanks, that was something that came directly from the airlines in particular. And also we had to engage with the current entities on the site, for example, the interplane operators who were taking fuel from the fuel farm out onto the apron. We had to deal with the fuel companies. Obviously, from a statutory point of view, we had to deal with the Commission for Aviation Regulation in Ireland, Fingal County Council and IATA, whom we've referenced before. And from an external perspective, even though Dublin Airport has its own firefighting capacity and facility and personnel, Dublin Fire Brigade are a key element in case of an emergency scenario. So it was a multi-party, internal and external stakeholder engagement, and all of them had to be involved, they had to be consulted, they all had to be afforded the opportunity to contribute to the formulation of the documentation by which we actually initiated this whole tender process. So we had a 2-stage tender process, an RFI and an RFT. RFI, request for information, followed by an RFT, request for tender. And there were 2 critical aspects of the RFI. The parties who expressed an interest in getting involved in the project had to have experience of at least one fuel facility where they were operating an aviation fuel farm and hydrant with 500,000 cubic metres per annum demand. If you weren't able to prove that, you couldn't qualify from the RFI process. And there were aspects associated with turnover. So we had a requirement that the aggregate turnover between the operator and the contractor would have to be the order of 35 million. And the aggregate assets of the operator, the construction contractor and sponsor in this context is effectively the financing entity within the consortium that was proposing to do these works. They had to have the financial capability of 94 million. From that RFI process, 3 parties effectively were identified and subsequently qualified to go forward to the RFT process. And of those 3 parties, one of them is represented here tonight, and we're going to find out from him shortly what his circumstances were as a consequence of qualifying for that RFT process and subsequent appointment. To give you an idea of the sort of timetable we were working to, the RFI was issued in October 2014, with the RFT issued in February 2015. So effectively, the RFI required, there was documentation, there was questionnaire, there were effectively hoops for the potential candidates to jump through. We then had to evaluate it, so the technical consultants were part of the evaluation process. DAA were part of the evaluation process. The legal team were part of the evaluation process, and on the basis of their collective thoughts and their collective evaluation, the parties went forward to an RFT, which, as I say, was issued in February 2015, with an expectation that the tenders would be returned in May 2015. And during that period, there was an opportunity, and in fact it was a requirement, that we would sit down with the qualified parties and actually have almost like a mid-term report back as to where they were in the process, to make sure that they were on track. And of course, as you can imagine, there was a fairly liberal question and answer scenario given the context of what we were trying to achieve at Dublin Airport. The concession was awarded in October 2015, and that was followed with the contract award in April 2016. And you might ask, well, what happened between October 2015 and April 2016? There's a slide coming down the line which is going to detail what happened during that period. But it wasn't just a case of, well, here's a price, go and do the work. It's a multifaceted aspect to this, and I'll elaborate on that one just shortly. Construction ultimately commenced in 2016, in July 2016, and from an operational perspective, the first tank came online in March 2018, and the Pier 4 hydrant was commissioned in April 2018. And currently, we are in a situation where the 3 new tanks are all in operational order. And from an airside perspective, what we're currently doing is extending the pipeline from Pier 4, we're going northwards in terms of ultimately connecting through to the Pier 1 and the provision of a hydrant at that pier. The middle photograph on the right hand side was actually taken from the top of the first tank, and it gives you in miniature form a sense of sort of congestion and the level of activity and everything else that was going on within the fuel farm during the construction phase. So some of the project challenges that we had to deal with. I don't mean any disrespect to my client. I'm not foolish enough to actually do something like that when there are at least two of them in the room. But it's a multifaceted organisation. There were different internal ambitions within the organisation and different considerations within DAA. So airside operations will have one perspective of the project. Landside may have a different perspective of the project. And we were in a situation where we had to make sure that both those entities could substantially achieve their ambitions. And I don't mean that in any disrespectful way at all. There's a late change to the configuration of the proposed works, and I have a drawing coming up shortly. And there was a multi-dimensional aspect to the tender submissions. So we had to look at financial models, i.e. the concessionaire, you look at the O in that, the operate, the F for finance. So in other words, we were looking for a party that was actually going to do everything on this project. They were going to design it, they were going to finance it, they were going to build it, they were going to operate it, and they were going to transfer it. So it wasn't just a tender to build up quantities. There were technical proposals to be assessed. John has made reference to the design of tanks, the design of pipelines. We had to ensure as DA's technical consultants that the drawings and the proposals that the successful concessionaire brought to us were in compliance with DA's expectations, that they were in compliance with the industry's expectations, that they were in compliance with design codes and practice codes and everything else. There were legal and employment undertakings to be considered. We had the interplane agents who are already on site. We had fuel suppliers. We had DA itself. So there were lots of legal and employment undertakings, and we've made reference to this different suites of documents that were put together. And not only did we have to actually look at the legal and employment undertakings, we had to actually get into a situation where we actually had to renew contracts with the interplane agents, the fuel suppliers, the airlines, and DA itself. And of course, there was a very substantial program of design and construction before we actually physically got onto the site in order to start carrying out the works. This was the original configuration that was expected. The yellow square on the far right of the picture is the fuel farm as it existed in 2014. The idea was that the yellow line that comes out of the bottom right-hand corner of the fuel farm and then makes its way to the second block of yellow colouring. The intention was that that second block of yellow colouring was an airside site at which we would establish an office for the interplane agent, agents, not plural. We'd establish an office for the concessionaire who was going to run the facility. We were going to look at putting in a vehicle service building in that vicinity as well. And then the intention was that the pipeline would then continue across the bottom of the page as you see it. There would be the red line connection to get into the pink hydrant, the pink line, which is the hydrant underneath Pier 4, and you can see Terminal 2 at the top of that picture. Then there was the offset in order to go into Terminal 3, or Pier 3 rather, which is the yellow line in the top left-hand corner. And in the bottom left-hand corner, the extension of the yellow line and its onward passage up to Pier 1. So ultimately what happened was the yellow block at the bottom of the page, that disappeared, and the buildings that were intended to go into that location effectively went back into the fuel farm. So we had a situation where 3 new buildings had to be constructed within the fuel farm while it operated on a 24/7 basis. And this is a photograph of the second and third foundation. So the foundation at the bottom of the page, you can see that the concrete foundation has been completed. You can see that there's gravel being inserted between the 2 concrete walls, which is the drainage mechanism. And then there's a membrane underneath, and the idea of the membrane is that the membrane will collect any leakages from the actual tank itself, and then they'll be put into a dedicated drainage mechanism that takes it outside the tank So in other words, that the concessionaire can monitor whether he's got a leakage problem on the tank. And then the foundation at the top of the photograph is tank number 1, and you can see it gives you an idea of the sort of the configuration of the tank. And it was an interesting time from a construction perspective in terms of getting those foundations in, and ultimately we've been successful in that regard. And as you can see, the fuel farm by night, as of the 9th of November, just passed. So that is my bit. Now, I've got this wrong, so let's go back to John's. No, I got that wrong, haven't I? Boom. Do.
Thank you, Cormac. I'm just going to quickly go through some of the commercial and operational issues that surround this concession. Starting with the point that fuel represents about 30% of an airline's operating cost. Depending on the price of fuel as it varies from time to time, it's a substantial part of an airline's cost base. And therefore airlines put a lot of attention into the cost of getting fuel to their aircraft, and the costs on the airport are particularly of interest to them. I would say there's been a traditional lack of transparency on what those costs have been. And from the 1970s, there were moves to try and change that, particularly in the United States. What we're talking about more and more is opening of the access to airports so that multiple fuel suppliers have the opportunity to supply fuel to airlines. Hong Kong was the first truly open access airport outside of North America. And what it meant was that any fuel supplier who met certain commercial and technical qualifying requirements could supply fuel to airlines. Even the airlines themselves could act as their own fuel supplier, and they could, if they were that way inclined, go to the spot market, buy a cargo of fuel, and have the right to bring it into the airport. At an open access airport, all of us tonight could get together and form a fuel supply company. And if we could convince an airline to buy fuel from us, we'd have the right at that open access airport to bring it to the airport and have it stored and handled by somebody like Ibon into our customers' aircraft. Compare that with the majority of airports, which are what we call closed access, where you can only supply fuel if you happen to be a shareholder in the infrastructure. Quite unlike the sale of fuel to motorists at service stations, where there are relatively few barriers to setting up in business, at airports there's quite a lot of barriers set up, and opening up of this access is key to what the airlines want. And from a very early stage, DAA said that open access should prevail. So we had to make it work. Mention has also been made of financial model. We put together a financial model in the tender preparation so that we could assess the levels of cost that this model would put on the airport operation. Fuel, as I said, is very important to airlines in terms of cost. It's also important to airports because if fuel is expensive, it means that airlines are not going to lift as much fuel from that airport as they might do. I mentioned at the very beginning that airlines have a choice and that they could, if they wanted to, not take fuel at a particular airport, but bring some of it with them. That choice always remains, and if fuel costs at an airport are prohibitive, they won't take fuel. They might even cut routes so that passenger numbers might fall. And for an airport like Dublin, which has other revenue streams it draws from passengers, like car parking, like retail in the terminal building, like food and beverage, loss of passenger numbers as a result of fuel has a knock-on effect that can be quite considerable. So we had to make the economics work and try and predict what they were. And we also had to provide a benchmark against which to evaluate the tenders. We weren't expecting huge numbers of tenderers to respond to this invitation because only very specialised organisations and entities could really respond. Relatively few parties would have the qualifying credentials. So we wanted to try and put together a financial model that would benchmark to give DAA something to measure a relatively small number of tenders against. The throughput fee is the tariff, which is the cost of using the fuel facility. Every fuel supplier, and if we were a fuel supplier tonight, we'd pay this exact same fee to the operator. We pay a throughput fee on a cents per litre basis, which represents the cost of using that system. The throughput fee is composed of a number of elements. I won't go into them all at this time, but importantly, there is a capital a facility cost, which recovers the cost of a multi-euro million facility over the course of the concession. There are operating costs that are recovered. Those are utility costs, labour, salaries, insurances, etc. And there's a fee that goes to DAA, and there are some reserves that can accrue. Investment recovery, the investment that is made in this fuel facility is recovered based on projected fuel volumes, which were the part of the benchmark of the financial model. There's an agreed internal rate of return, and the recovery is based to an extent on the profile of risk between DAA and the DFBOT concessionaire. The concessionaire, in terms of operation, is fully responsible for operating the facility and keeping it available on a 24/7 basis throughout the year. The concessionaire also has to provide and maintain and keep open access fuel supply working. They have to qualify the fuel suppliers, so any applicant who knocks on the door and says we'd like to supply fuel has to justify why and how they're able to do that, and that they have an airline customer whose fuel they will take. They have to demonstrate insurance, and we also have to bear in mind that because it's an open access airport, fuel suppliers can come and go. They can come and they can supply fuel to airlines for the duration of a contract, which may be 6 months, it may be several years, and they may go away again. They may not decide to supply at Dublin again. Quite unlike a closed access airport where the oil companies would be part of the permanent establishment. This airport here in Dublin, with its open access provisions, gives a lot of flexibility. The concessionaire, the operator, we're going to hear a bit from Ibon later, is what we would call, in legal terms, a bailee of others' fuel. They look after the fuel suppliers' fuel. The fuel suppliers deposit their fuel into the storage at Dublin Airport, and that's the end of their physical relationship with the fuel. The operator stores and pumps that fuel and moves it towards aircraft, and they have a duty of care. They have to look after the quality of the fuel. They also have to look after the quantity. They can't afford to lose a single litre of somebody else's fuel. They have to keep that facility and the fuel in it available 24/7, 365. And they also have to report to the stakeholders what they've done with that fuel, on whose account an aircraft has been fuelled, in order that the particular fuel supplier knows when to bring more fuel to the airport. They also have to manage a finite amount of storage, because the tanks, whilst big, 5 million litres each, are of finite size. And if fuel suppliers were allowed to store as much fuel as they liked, it would effectively keep other fuel suppliers out. So the capacity or the amount of cubic meters that each fuel supplier is allowed to store is worked out, and it's a moving target because market shares shift, but it's generally based on market share of that particular fuel supplier. We also had to make sure that the concessionaire complied with industry requirements. There are a whole raft of industry requirements that have to be complied with. Some of these acronyms may be familiar, some may not be. EI is the Energy Institute from the UK, API is the comparable body from the US, American Petroleum Institute. IATA we've mentioned before. JIG is a standards body that arose from the major oil companies and their requirements to inspect each other's facilities when in joint venture. Is now one of the industry developers of operating standards, and SOPs, standard operating procedures, are important, and we had to specify what those should be in order that DAA could be assured that the fuel facility was being operated on a reliable, safe and efficient basis. And airport fuel operations are used to and subject to inspection at regular intervals to ensure that they're complying with industry requirements, with airline requirements, with regulatory requirements. Fuel is flight safety critical at the end of the day, and it has to be made sure that the operation is safe. I'm now going to hand over to Ibon, who's going to tell the story as the concessionaire and operator.
Thanks, John. Good evening. What I'm going to explain is what is CLH, what is the fuel farm project, the calendar and the construction phase that we're going through it, challenges of the project, and a summary of what CLH Aviation. So CLH Aviation Ireland was a company created 100% owned by CLH Aviation. That's my former company where I used to work. That it's 100% owned by CLH Group. CLH Group also owns CLHPS, that it's a logistic company in the UK, and we have some joint ventures with a terminal in Barcelona, Bopac, and a project in Oman with Orpic, that's the government of Oman. So to give you a view of what is the CLH in Spain, this is a network of the pipelines, the terminals that we manage, 39, airports, 28, and then also entry points for the logistic network. So CLH will manage the fuels, all type of fuels, so not only aviation, but also cars, diesel, and others, as a bank. So you can put at an entry point in, let's say, Barcelona port as a supplier fuel, and you can take it out at Madrid Barajas Airport immediately. So it's like a bank account. It doesn't have to wait to the molecules to move through the system. So that is how it's managed. Also, because of proximity, I include this slide. So you have a view of what the system that we bought in 2015 in the UK, that it was the former GPSS logistics system. As John mentioned, we don't own the fuel, we just manage it. We're an open access system, and that's how we've been working since we were privatized CLH in Spain in the 90s. And this similar process is going in the UK. So because they privatized this network, they want a private company to buy it, and that's where we appear. This network moves 90% of jet fuel through the network, 16 fuel farms, and actually I'm going tomorrow there to have a meeting with them. Also, we have some other projects going on in aviation in Panama, and we're tendering some other countries because CLH is expanding internationally. Going to what we want to talk about here, that it's Dublin Airport project. So similar to Colman, I was invited to IATA meeting in 2014 that it was held here in Dublin. So IATA will be do big meetings for the fuel industry twice a year, and one of those meetings was here in 2014. And we were walking on the corridors and we saw a little stand of DAA saying Dublin Airport opportunity. We're like, let's have a look, what's this about? And here I am. So the project, it was what they have explained, design, finance, build, and operate a fuel farm. because CLH at that moment, it was looking for opportunities outside. We put a lot of efforts. I have my boss that came to me like, would you like to help me with the tender? And we're like, yes, why not? I've never been in Ireland, so let's go for it. And we prepared the tender, we went through the process that they have explained very well. And here we are, we were awarded, and we were awarded as concessionaires to take over operations in the fuel farm and start building the new fuel farm on the same space that the fuel farm that I was there was running. CLH Aviation Ireland was a company created to do this work, and I came over here to build it. That's how the fuel farm looked when I first arrived here. The three small tanks that we have mentioned, all loading bays, some old buildings for the into-plane and the people that was operating the fuel farm, and the offloading base. And that is how it looks now. As they explained, we have built the 3 tanks. Hydrant system was built by the IATA when they built the Terminal 2. We just connect the pipelines to the Pier 4. We do a lot of checks because the pipeline was there for several years, so we checked that it was integrity, it was clean. As John mentioned, very insist on that, is that the quality, there's no backup on the fuel on an airplane, so we did a lot of checks on the system. And we keep going. There are pending works like the offloading base, new offloading base, and we're getting there. That's the view from one of the former tanks that now is a water tank for the firefighting system, with the 3 tanks, the offloading base. And this is what it's going on the air side. So the blue line is the pipeline that is currently working, and the pink Pier 4 that you can see this the pier on Terminal 2. And actually, to give you figures, 33% of the fuel that we deliver to the aircraft on a daily basis goes through the hydrant now. As you know, Pier 2 will have all the access to the passengers that they're leaving to the US, so they have the pre-customs there. So most of the long hauls depart from Pier 2, so most of the long hauls leave from there. Benefit for the into-plane agents, that those are the company that take the fuel from the fuel farm to the airlines, and they will be working on behalf of a supplier that, as they explain, are the owners of the fuel. The benefit that it has created them is a lot of saving on human resources, and a lot of saving on also movement of vehicles from the fuel farm to the airport. When going through security can take you like 20 minutes or 25 minutes. And then if you're, I will take San Francisco, for example, that it was the first plane that we refueled from the hydrant. That could take 3 full trucks of fuel to be filled. So that is a lot of, and as John mentioned, planes do money when they're flying. They have very tight turnarounds most of the time, and the timing that it's saving for the airlines on that, it's very important, because they can reduce the turnaround on the fuel. We keep going with the work, so there are a lot of pipes, and Colman is doing a lot of efforts with all our project, all our contractors and people involved in the project to keep going towards Pier 1. Big challenge because of the congestion of the airport. We'll get there. So Pier 1 will happen, and then Pier 3, that it's the small little round next to Pier 4. The project itself, so it was divided, when we prepared the tender, we divided in 3 main phases of the project: the transition period, and then construction that overlap with operation, and operation. Operation will be 20 years, because that's what the concession agreement with the DAA said, that we're going to be operating the fuel farm and the hydrant that we are building for 20 years. Transition period was a window of time between being awarded and taking over operations, where I start coming over here. So one of my first trips here was with HR people, recruit 12 Irish lads, and start building the company itself. Checking how the fuel farm was, learning how it was operated, equipment, all the facilities that they have, how we could integrate those facilities into our operational procedures and start working from that. One day at midnight, we took over operations. Former company that was there, I have to say that they helped us a lot to start our activity. We get the books and start running the place ourselves. At that time, we start also building the new fuel farm, and it was meetings arranged with the into-plane agents because they lived there with us in the fuel farm to agree things that were the commissioning and commission. So you cannot decommission something if you don't have that thing commissioning somewhere else and it's working and you have tested. So it was a big puzzle, and it was still challenging, as Colman can tell us. This is a schematic of what's happening in the fuel farm. As they mentioned, fuel suppliers, owner of the fuels, we have what we brought to Dublin from day one is open access. Supplier, contact me, let's have a contract in place. Bring me the fuel, I'll take care of it, and then you get it into plane and put it on the airlines. So the fuel suppliers, they have an obligation to bring us fuel in spec, good quality. We check it on each truck, and then we put it in the fuel farm, we take care of it, we do the drains, to do the quality checks, and we make sure that when they take it at the loading base of the hydrant, the fuel is good for the airlines. As John mentioned, that is all covered by the throughput fee, and that will integrate all the services that we give them. We also have a strong level of insurance because of the liabilities that you could incur on things happening. And also we obligate to the suppliers to have a lot of insurance that we check, and we communicate to the DAA if they are in breach with that. What we were preparing the tendering process, we get a lot of data from the DAA, and we identify big challenges to go through. So some of them are shown here, and mainly was very small capacity and congestion on the offloading base and the loading base. And that could have a lot of impact. And also it was a lack of backup things, like backup power supply and backup equipment in case of something failing. For the shortage of the capacity, we put as number one of our milestone building the first tank to fix it as soon as possible. But as you saw, they're big tanks, and it will take long. So we put as the very first thing to do to build a new new offloading bay. There was 2 offloading bays, and we identified that the priority was to be able to fill the fuel from as quick as possible. So we increased 33% of the capacity of the offloading process, and that helped us to go through summer 16 and 17. In summer 17, we already did have the new tank, but the filling of the process of filling was the key to be able to keep the operations on the airport. And actually, we went through without any fuel disruption during that period. During the construction and when we start building the fuel farm, things that challenges that we went through, it's we took over operations in June, peak time of the year. So a lot of people came from Spain to help us because it was a very day-to-day learning process. On the transition period, we were allowed to observe, but we were not allowed to touch or do anything in the fuel farm. So we just kick in, and we have the support of these people that they were previous to us, but it was a learning process. So there were things that they were not working as we expected, and there were things that they were not as we thought that they were. So it was day-to-day adjusting and going through it. Also, as I mentioned, identifying that it was only 2 offloading bays. What we did is we start commissioning the 3rd offloading bay in a plate on the top of a container. So the bay came in a ship to Ireland. As soon as we took over operations, we put it, placed it, connected, and it was working after 3 weeks of being operating the fuel farm. And that was a key thing to keep the operations on the airport during the summer of 2016. Also obtaining the license of the HSA, because the site was jumping from 2.4 million liters into 15 million liters. It was going to a higher level as Coma Seveso regulation. So we have to deal with the HSA to get the license. We get the license on time to be able to fill the tanks and the infrastructure as it was built. Also, the IATA, as a regulator of the aviation, they have to extend you a license of fuel farm operator and hydrant. So after a few days we took over, they came, they inspect us, they check all our procedures, and they give us the license. And then after a year that coming, it was on the first year it was findings, but on the next year that they come, there were no findings, and they were very happy with the operation as CLH was doing. As I mentioned, keeping operations without disruptions at Dublin Airport, no fuel, no planes take off, with facilities that they were 40 years old, no backups, no lack of some information sometimes. It was a challenge, and it was a lot of people that helped us from Spain. It was a lot of people that came to give support. So big challenge, we went through it. And then managing the capacity, the small capacity, until we were with the 3 big tanks that it was last year and this year that we've been operating with the 3 tanks. It was days that we were filling the fuel farm like 3 times. It was non-stop coming, tank empty, going. I mean, the small tanks, they could last like 1 hour and a half of activity, to give you a view of how quick the fuel need to come in. And it was just on time. If you identify disruptions on the supply chain, calling suppliers, what's going on, you need to tell me, you need to bring the fuel in right now. So they've been very supportive on that also. So it's been a lot of work of all the parties, all the stakeholders, until we have what we have now, that we have over 3 days of capacity at the fuel farm. And then, and Colman can talk more about this than myself, scheduling construction works and make them happen while the fuel farm is operating, with a lot of stakeholders there that you need to agree with. We're going to put this, we're going to take that, that's going to be gone. So it hasn't been easy, it has been challenging. There been moments, good ones and not as good ones, but things has gone through, mainly in the fuel farm. Fuel farm is almost finished, so like the big thing now, it's a lot of work of Colman with operations, and it's a lot of people on the air side that we need to deal, even the IAA sometimes when we're bringing cranes. So those are not easy jobs, but we're almost at Pier 1. So we're getting there. And then also, when we took over, as I said, we were learning by the way that we were using the fuel farm and the equipment. So the capacity of being able to change procedures from one day to another, and the effort that it requires for management team to reach to everybody. When you're in a 24/7 operations, you have people that it doesn't stop. So to reach to everybody, it's very complex. If the people go on day off, then they come at night, and then so it was difficult to do that. It was a lot of people that, as I mentioned, came here to help us, and I think we did it very good. Now we have a great team, and also the DAA and all the people that is involved in the project. So we just need to finish Pier 1. And summary of CLH, so some pictures. I put some pictures there of how did it start. So that's me with Nuria coming to do recruiting. So for 10 days non-stop, 8 to 8 interviews to Irish people, getting the people into the team. Then a picture there, taking them to Alicante to train them. Javier came in to help us to train the people here, to teach them the difference of the things that they saw in Alicante. It was a brand new terminal, and actually it was the example that we put on the table to the DAA to tell them, we have done this. We have taken a fuel farm, converted it into a new one, and we have built a hydrant. So we thought that it was a good example for the last to go to Alicante and see the new terminal. So we went there, trained, then pictures of Ricardo that came to help us also. Kick off, that's when we took over. That night, that was the beginning. how we manage the fuel farm, it was so CLH is a very fully automatized system. Now from the operations room, we can control the whole thing. We open valve, close valve, check the level of the tank. Everything is on the view, on the screen. That whiteboard was what we have on those days. So check the levels of the tank, go to the tank, check the level. It was very manual, and we have this comment like, oh, if the power goes off, only the pumps doesn't run. The rest of the things will be running, because it was all manual. So, but it's, then pictures of the tank, of the structure of the tank 1 and tank 2, shut down during the storm. That was something also that I never went through, like call, go home, we're closing, and then come back, we're opening, and how those situations were managed, and how we work with the DAA to clean things and knowing when aircraft will we be needing the fuel at the wing. Because when the country shut down and say, no, you don't have to come back to work until Monday. Well, airport is not the same. Airport says, Saturday 8 a.m., we want fuel. And sometimes it's complex when you have people that they don't live close to the site and roads. And so the team was very supportive on that. So the people that lived close to the fuel farm, they were very helpful, and they offered themselves to come and help. And that's why we were able to do it. And some pictures of the commissioning with the storms and that, and metering in the first time. So, and things that we have get. So the first refueling of the hydrant that happened this year, as I mentioned, the flight to San Francisco. Then the plane landing from the top of one of the water tanks, used to be a jet tank, and watching the 3 tanks on a sunny day in Ireland. And then me picking up some of my awards, that fuel facility, fuel management awards. So yeah, that's the summary of CLH Aviation Ireland here in Dublin. And thank you.
So this is just the concluding part of the presentation. Okay, so that concludes what was a very, very interesting set of presentations. So before I throw it open onto the floor, I'm just going to thank the 4 speakers. So thank you, Colman, thank you, John, thank you, Cormac, thank you, Ibon, for what were very interesting talks, very, very well thought out. Clearly a lot of work went into the presentations, so thank you very much for that. So before we move on then, can I, in the question and answer session, can I ask people, before they ask a question, to just introduce themselves and to introduce the organisation which they're representing this evening. And I'll have a roving mic that I'll use for this. And can I ask the 4 speakers maybe just to come back up to the podium for the question and answer session, just to assist with the webcast which is ongoing. So has anybody a question then that they'd like to ask any of the speakers?
Thank you. My name is Michael O'Kane. I'm a freelance engineer specialising in regulation compliance within the oil industry in Ireland. So first thing that hits me is that the site seems quite confined, and I'd like to ask Ibon that question. How does that site compare to many of the other sites that you operate, size-wise?
It's very similar. So the standard, more than the operations itself, well, when we took over, it was the limitation of the infrastructure. As we have been building, we have make everything adjust to CLH operational processes, so control and that. So it has been adjusted to CLH standard that it's coming from GIC and Energy Institute. It's aviation industry is very similar. You need to have, as you mentioned, filtration, quality check, and it's very, very similar everywhere. I don't know if I'm answering your question.
Yeah. So on the old tank farm, which consisted of three much smaller tanks, the space available for general truck movements and other ancillary activities seemed quite adequate. But on that confined plot now with the extra tanks and the extra buildings, space seems confined. I'm sure it's approved and it obviously works, but I'm just curious. The older tanks, normally with tanks you have a bund, tank farm bund, and the new tanks, as far as I could see from the slides, didn't seem to have a bund. But I note that they are double skin tanks.
Yep.
Is that the reason?
Yeah, they're a primary and secondary containment. So the primary containment is obviously the tank wall itself. The secondary containment is a concentric ring around the tank, which is 2 meters offset from the primary, and there's a certain element of tertiary containment in terms of the actual footprint of the bund itself. In terms of the actual vehicle movements, which you've alluded to, effectively the vehicle movements and the operation of the fuel farm was an ongoing review on a month-by-month, well, not even a month-by-month, a week-by-week basis. So in other words, as the construction activity moved throughout the fuel farm, the movement of vehicles in and out of the vehicles, the movement of fuel bowsers in and out was changed on a week-by-week basis in accordance with the actual construction activities. But you're quite right, it was confined. The other aspect of it, it wasn't the original intention that the 3 buildings would go into the fuel farm. That was a change that was necessitated as a consequence of other considerations of the project.
Now take on board also that 33% of the volumes, it goes through the pipeline to the hydrant. So it has been and Colman can tell, it was a time a year ago when closing the loading bay was like the end of the world for the into-plane agents. Like, no, you can, when now you can close 2 bays for days or week and nothing happens, because all this big bulk of fuel that it's going to the US on the planes, it goes through the hydrant. So it has been a major reduction of trucks coming to get fuel to take it back to the apron. We haven't reduced the trucks coming to bring the fuel to the fuel farm, and we're not expecting that they will be reduced as we're seeing how the tendency is going, but that has reduced mainly the activity. I mean, the trucks coming and going back to the apron. So that has helped a lot. And once we keep going to Pier 1, it will be improved. I'm expecting that probably when Pier 1 is working, more than half of the volumes going to the apron, it will go through the hydrant. With the small cars, it will be a big reduction on number of fuelers, so it's going to be much more efficient.
Okay. Just on those tanks, those are relatively, well, they are new to Ireland as far as I'm aware. Are they quite a normal tank form of construction of tanks in other facilities which you operate? No, and it was something that it was required by the planning permission of the site.
They're more common in the Germanic countries, actually. Austria, Germany, Switzerland have probably more of this self-bunded tanking, if you like to call it. We call it tanking.
And actually Colman and myself and some emergency teams from the DAA, we went to visit a site on Germany of people that I know of the industry, that they invite us to spend the day with them and put together safety equipment that we will need to put in place for the tanks.
We brought Dublin Fire Brigade over because, like you said, this was new to them, and they wanted to understand these tanks.
New to everyone.
So we brought them to Frankfurt, and in Frankfurt Airport they have an installation with 186 million litres of storage in cup tanks. And we walked, we got the experts over there to talk to, and some of the fire guys over there to talk to Dublin Fire Brigade guys, and they got it. They got the understanding. And there's a lot of safety systems in this tank, in terms of spreading of foam and firefighting systems or whatever. So there's quite a lot of top spec equipment on it.
Is there a specification to which, or code of practice or specification to which the tanks are built?
API. So they're built under API 650.
API.
Yeah.
Okay.
But these are, so the double skin tanks, they have specifications in Germany because their legal requirements are to be built by that. So a lot of things with the double skin tanks come from Germany, and they've been there in the industry for long, since long time. So a lot of things are learned from the Germans in this regard. But the tank itself, how to build it, it's API. So CLH will follow API 650 to build the tank.
And does that IPA also indicate the separation distances between tanks for that particular construction? There's a specification for building tanks, and then there's a code of practice for separation distances between tanks. So the tanks are of new construction, and the separation distances. I'm just curious as to what that's based on, what reference document that might be based on.
You're referring to that code of practice. The number escapes me. That sets out separation of tanks, and they do meet that.
Okay.
They do meet that.
Thank you.
Yeah.
Larry O'Toole from DAA. Just want to congratulate the four speakers on an excellent presentation and commend the respective organisations on delivering really an excellent project, fantastic project. Question possibly directed more towards John, but the others may want to contribute. The open access model is still a relatively unusual model in the aviation industry, and now that the project is up and running and is a success, what's the perception in the wider aviation industry, and is it encouraging more airports to look at the open access model?
Sure. I think that IATA, the airline representative body, encourages open access wherever it can be implemented. And the word implemented is important because the opportunities are not huge. You need some form of change, such as a new airport, when you can set the terms of reference, or the airport can set the terms of reference with a clean sheet of paper, or some other change, such as effectively happened here in Dublin, where the incumbent oil industry quit and decided it didn't want to be operating the fuel facilities anymore. So there was an opportunity to implement something new, a new operating model. You're right that the incidences of open access are relatively rare. Hong Kong was the world's first interpretation of open access outside of North America. It's since been rolled out in several airports in India, Bangalore and Delhi, although the degree to which open access is possible there is not fully in place yet because of various government restrictions, but all the documents are on the shelf, the agreements are there ready to fully implement when necessary. Nice airport is open access, and several others are in the pipeline. So I think the airlines, as the pullers of this through the supply chain, are happy to see open access wherever it can be implemented. And one quote from 20 years ago in Hong Kong was that, notwithstanding the fact that there was an expensive fuel facility at the new airport to pay for, and the airlines as the users are ultimately paying for it, at the new airport in Hong Kong on day one, there were 13 fuel suppliers in an open access environment, as compared with the old airport at Kai Tak. The previous day when it closed, there were 7 fuel suppliers, and the airlines said that they were paying no more for fuel at the new airport with a $250 million facility to fund than they had been at the old airport. And that's 20 years later, and a lot of competition under the bridge is still very true.
The feedback we're getting now is that it is good. Now it takes time for it to work its way through the industry, like in terms of tendering periods. But we have one new fuel supplier, and there is expectation that there's a few more due to come in shortly.
Kieran Doyle from the National Development Finance Agency. Just a query, maybe everybody has an input in there. Very good presentation there for a start. Was there consideration given to starting from a blank canvas, relocating the fuel farm? If so, were there deciding factors there in maybe retaining that prime real estate where it is? Or what was the thoughts on that?
Hi, Kieran. I'll take that. As John said, back in 2006, the fuel suppliers as a collective went and got planning permission. And it was during the boom, and they could see that unless they redeveloped this facility, it wasn't fit for purpose as the boom continued. They wrote to Dublin Airport in 2008, and they said that they weren't going to progress with the development without planning permission. And secondly, as John said, they were actually going to pull out from managing the facility in 2014. Now the reason they did that, it was not a boom bust. It was as a global throughout the fuel industry, the majors are pulling out of downstream infrastructure. They're just collectively selling all their old infrastructure and handing it off to other people. So Dublin Airport was faced with the problem that we needed to develop it. Now 2008, it felt like there was time to get it, but a number of years went by in terms of how it was going to be done, how it was going to be financed. And my little bit of Latin tempus fugit, time was flying. The boom was kicking in. So by the time we got to this, we didn't have the blank page. Now I know in 2008 they looked at various other sites around the airport and they'd come to the conclusion that the existing site was the site to be developed. But when we got to this stage, and when it got to the stage of procuring all these gentlemen and then the companies that came with them, time was against us, and we had to deliver fuel. And as Ibon says, until we got the first fuel tank up and running, the airport was, we were literally on a knife edge to keep the place running. So that kind of, the luxury of going back to the blank page was gone, and it had been done. And this was case was deliver what we have in front of us and get it done. To some extent, coming back to your point about it's a tight site, we recognise that, and we looked at putting the interplane agents and the interplane base airside and piping the fuel to them, which a lot of operational betterness to it if we could have pulled it off. But Dublin Airport, as Larry knows, is massively growing, and we're very constrained on the east side of the campus. Sorry, I've got that right now, on the east side of the campus. And space is at a premium. So the very place we were going to put the interplane agents would have moved a lot of trucks and freed up a lot of space for us. Now it became more valuable as additional stands. This happened during the tender process, and Dublin Airport said, no, we want that land as stands because we need stands. So we went back to the original plan, which was to redevelop the facility within its footprint, which was the original planning application that had been achieved. So it's a case of dealing with what you're handed in a very constrained, but also a very fast-growing place, but the need to get something in place. That's what dictated where we are.
And in actual fact, the airside interplane base is already under concrete of the apron.
But it is the stands.
So it's gone.
Keith Elliott of PM Group. Again, congratulations to all of you on really interesting and informative presentations. My question is not directly related to the facility. It's I'm just fascinated as to why at this stage, with the volume of fuel that's being transported to the airport, that there isn't a pipeline. And you've said that there is a private interest in developing one, and I can see why there would be. But I can't for the life of me understand why DAA wouldn't be interested in that.
I'll take that. It is a private company, and one of the companies involved are Reynolds Logistics, who are actually one of the companies that deliver fuel to the airport by truck. So, in fairness to, I think it's John Reynolds, they could see that the writing was on the wall in terms of truck deliveries. And the ability to sustain that, because as Ibon says, it's literally 24/7. We've, I think during this summer we had days when we had in excess of 120 deliveries. And the old day, in the old days with the old tanks, the difficulty was making sure there was enough ullage in the tank to get your deliveries in. And that, literally, as Ibon says, we're up there with the whiteboards trying to figure out the deliveries just to keep ahead of the curve. So a pipeline makes sense because a pipeline can be delivering 24/7, every minute, day, constant flow rates. I understand the regional pipeline, I think it was back in 2001 they looked at it to go for planning permission then, and I don't know if they went for planning or it fell by the wayside, but it reinvented itself just when we were actually developing our project back in 2014-15, and they went for planning permission and they achieved it. They finally got the planning permission. Our facility is set up that we have a pipeline receipt, and if the sooner comes the better, because Dublin Airport is probably the last airport major international airport in Europe that isn't pipeline fed. So from our sense it would be good, but for one reason or another they don't seem to have progressed at this moment in time, and they're still working through various issues. I think they have to deliver that piece of infrastructure. Did we consider investing it? Yeah, there were a number of discussions on should we or shouldn't we. Still mute.
If I may interject with one question for John. John, you mentioned in your presentation the susceptibility of aviation fuel to microbial contamination. And in that context, I'm wondering, is there any need for temperature regulation in any of the tanks? And secondly, then, whether there is monitoring for microbial contamination of fuel that's stored in the tanks?
Yeah, daily, standard operating procedures, daily housekeeping checks mean that samples are drawn from the centre sump of the tank, and it's also possible to draw samples from upper, middle and lower levels in the tank as well to get a view through the depth of product. And yeah, you're right, checks are done to check for levels of dirt, water, and visually for microbiological contamination. I think it's fair to say that microbiological contamination will occur when housekeeping procedures are poor, and that when water is not constantly removed from the tank or the filter or wherever the sampling is done, and that the spores that propagate themselves into colonies are airborne pretty well all the time. But normal procedures of removing one of the components they need to survive is generally quite effective at removing them.
Okay, thank you.
Chairman, I too would like to add my congratulations to the four speakers on a fine presentation, not one we often get in this in this house, you know. However, I found it very complex, I have to be honest, and I particularly the financial model, and I'd just like to ask a few simple questions in layman's terms. I'd like to know what it costs the client, and I'd like to know in simple terms how the operator gets paid. I have a few questions if you don't mind. I'll be fast. You didn't talk much about environmental precautions, and I'd be interested to know that. I couldn't hear with all that fuel in Dublin Airport what the carbon footprint might be up in the sky when it's taken on board the planes and there's emissions. And the other one, the conditions of contract, but it's such a complex contract. I'd like to know. I'd be interested to know what the conditions of contracts were. But just again, say what it costs the client, how the operator gets paid. And sorry, finally, a nasty question. I think maybe is there a final count figure?
Yeah. I'll take the one of the environmental, maybe leave you the other ones. So CLH is an ISO 14035 company, so we have environmental procedures in place, and we check the quality of the water of the interceptor and things like that. So our footprint is not massive about pollution, because all our movement of fuel is based on power. It's by pumps, but they're electrical pumps. So we don't generate CO2. It will be more the trucks, refuelers. So actually, with the commissioning of the hydrant, we have reduced that footprint also of the emission of the big trucks bringing the fuel to the aircraft. So that's an improvement. And as I mentioned, the company actually in these 2 years, we have been 35 on the 9,000, 14,000 and 18,000 as part of our integrated management system.
Also, in the context of environmental, one of the stakeholders within DA was their own environmental and social department. So in actual fact, they were one of the few entities who actively contributed to the relevant drafting of that section of one of the suites of documents. So while there was a stakeholder process, a large part of the stakeholder exercise was actually advising people what the implications of the project were, what we were actually going to do. And the vast majority of them in Colman were saying, right, okay, we now have an awareness of the project, we understand the implications of it, but the environmental team in particular came back with specific clauses that had been incorporated in, for example, operation of vehicles, things like dust suppression, things like environmental control. As you can imagine, the whole airport campus is a very strictly regulated environment, and it's getting even more strict in terms of what you can or cannot do in terms of, for example, if you have a contractor who's working airside, the number of people, number of subcontracted personnel he can bring in is shrinking, and that's because there is such an environmental awareness, there's such a security awareness. So, in answer to part of your question, yes, there was a very significant environmental awareness, and of course that was enhanced by the fact that you're trying to carry out construction activities inside a fuel farm that was operating 24/7. So, for example, something like dust, which is increasingly an issue for any construction site, is of much, much more enhanced significance when you're actually dealing with fuel. Some of the financial questions.
Well, I go through the contract and the financial questions. Conditions of contract, it's a bespoke contract. And it's not a construction contract in the normal nature that we're all used to. It's actually a concessionaire services agreement. And I mentioned Aaron Boyle from Arthur Cox's was key to the writing of that. I have to say I'm very impressed with his level of understanding and the grasp of how to look at this. It's a 20-year concession, and the way the financial model works is that the airlines tender for fuel suppliers. The fuel suppliers send back a tender for delivering fuel into their aircraft, and they cover all the things from, as John said, from a refinery to shipping it over from England to Ireland, to hauling it from Dublin Port to the airport, the throughput fee for putting it in the tanks and the management thereof, and then the cost of the interplaning agent for delivering it into the plane. And the granularity of that and the way it's tendered is let's say, is an opaque business between airlines and fuel suppliers. But the way the operator gets paid, and they're the DFBOT entities, they get a throughput fee for every single litre that the fuel supplier delivers into tanks, as the fuel supplier pays that as part of his delivery cost. And this a 20-year concession then generates the capital expenditure to deliver the facility. And the facility, in terms of infrastructure costs, we're looking at a 40 to 50 million type piece of infrastructure. and they build that and they develop it and then recoup their costs over 20 years. And that's the financial model. Does that help?
And the throughput fee is the same for, in a per litre basis. It's the same for everybody. So the degree of transparency, it is transparent to those who need to know, the airlines and other stakeholders.
We were very keen, and as John said, a lot of effort is going to understand that the development of this facility and the associated throughput fee that would go with it, which is what the tenderers were tendering. They were tendering a throughput fee per litre. It had to be of such a level that it wouldn't make business in Dublin Airport unsustainable for the airlines. But then at the same time, it would have to be at such a level that the operator would make money, the infrastructure would get developed. And we even, like in our tender, we tendered 2 concession periods to see did that make a difference. So we did 20-year and a 30-year. But from the airport's perspective, the sooner it was delivered, the better, and it gives us more control of the infrastructure. But at the same time, if the 30-year had developed a significantly lower throughput fee, then we would have to seriously consider that, because we couldn't be creating something that would become a barrier to the very business that we were trying to encourage into the airport.
Okay, have we any final question? Okay, so what we'll do then is I'm just going to hand over now to Oliver Russell for the vote of thanks, and Oliver is the current treasurer of the Institution of Civil Engineers, Republic of Ireland branch.
You got it pretty well right. Now I found the presentation particularly exciting and informative, because while I know very little about aircraft and fueling and all that type of work, I am involved in North County Dublin and lived quite close to it, and being part of Fingal Chamber, I'd be at lots of presentations with the DAA and how Dublin Airport is going to develop into its 45 million people, which is passengers, which is wonderful. But it's to see it all coming together. And I also got, during the course of the year, as with Cormac, I got a visit to the facility in February when we had the president of the Institution of Civil Engineers in Ireland on a visit, and we got we saw the facility in place, and it really is compact, and it works. It's really fascinating to see it going. So I was really fascinated with the presentation. First time I've ever been with 4 separate ones, each equally fine. Although I think Colman, you sneaked off very easily on a small little bit at the start, and it's just as well you didn't run away from it. But anyway, with what's going on, and having heard about the pipeline since 2001, it's been around. Anybody in North County Dublin in engineering would have heard about that one. And with your new runway, which I have the contract signed for, all is going well. So I found it a wonderful presentation. All these searching questions from yourselves, I have nothing else to answer, add, except I'd like to propose the vote of thanks. And while you all show your appreciation in the usual way, please, to the four gentlemen. Thank you.
So that concludes the presentation for this evening. And just before we depart then, I just have a little memento for the speakers for the evening. Thanks, John.
Thank you.
Thank you.
Thank you very much.
So thank you very much. That's where we leave it at for this evening. And thank you all for your attendance on a night that was very inclement, and I'm sure you could have been doing plenty of other things on such a terrible night. So thank you all for your time in coming this evening. Thank you.